the controlling body of world astronomy, the IAU, took Alpheratz away from Pegasus and transferred it to the next constellation, Andromeda. And I don't know why that was, because Alpheratz clearly belongs to the Pegasus pattern, and Andromeda really has no marked pattern at all. In mythology, it represents a princess, but certainly I can't make a princess out of that pattern. And certainly, to me, Alpheratz does appear to belong to the square. We've got a picture here which shows where the linkage is. Up in the left-hand corner, we have the brightest star of Perseus, which is Merfac. Down to the lower right, two stars of the square, Alpheratz and Scat. And the Andromeda is marked by the line of stars running down from the top left down to the lower right. And they're the second magnitude and quite easy to find. And two of them are decidedly orange, about the same brightness as Alpheratz. These are Mylax and Almach. And beyond them, we come to the variable star Algol in Perseus, the eclipsing binary. But Almach is an interesting star. With the naked eye, it looks perfectly ordinary, orange second magnitude star. But telescopically, it is seen to be double. And there's an impression of what Almach looks like through a telescope. And because the magnitudes are just below 2 and just above 5, almost any small telescope will separate the two, and it's not very far beyond binocular range. And I always think of that as one of the loveliest double stars in the entire sky. But, of course, the most celebrated object in Andromeda is the great spiral Messier 31. Messier was the great French astronomer who catalogued these things way back in 1781. And M31 is the nearest of the really large external galaxies. You can see it with the naked eye, but only, I'm afraid, on a dark night, so again, you've got to wait to get the moon out of the way. First of all, start with Mylax, sweep up to the two fainter stars, Nu and Mu Andromedae, and there, slightly to the right of Nu, you will see the hazy patch which marks M31. This is a photograph, on small scale, taken by Commander Hatfield. There is the great spiral right in the middle of the picture, and that's the kind of view you're going to get with binoculars or a small telescope. But of course, when you photograph it with a large telescope, this is the kind of view you get, and you see there that in fact it is a spiral galaxy, rather larger than our Milky Way, but placed at an unfavorable angle to us, so the full beauty of the spiral is unfortunately lost, but I think it's a great pity. If it were broadside on, it would look like a huge Catherine wheel. And nearby, there are two more satellite galaxies. Down to the lower left is Messier 32, and to the upper right, NGC 205. NGC stands for New General Catalogue, which is now more than a century old. And these are not spirals. This is a picture of M32, it's an elliptical galaxy, and a rather irregular one, NGC 205. And they are much smaller than M31. Now, in fact, M31 is rather over 2 million light years away. So when we look at it, we're seeing it as it used to be 2 million years ago, and it's a huge system, larger than our own Milky Way galaxy, and containing more than our own quota of 100,000 million stars. The first man who proved this was Edwin Hubble, after whom the Space Telescope's named. And what he did was to study certain interesting stars inside the Great Spiral. And these are known as Cepheid variables. They change in brightness in the same way as Scat does, but they're different kinds of variables. They have short periods, and they're very regular. And the way in which they change tells us how luminous they really are. And of course, if you know how luminous a star really is and how bright it looks, then you can tell how far away it is. And that's what Hubble did, and proved for the first time that M31 really is an external galaxy. He got the original distance rather wrong, but now we know it is over 2 million light years, and so we're seeing it as it was more than 2 million years ago. It's a member of what we call the local group, and even at that distance, it is still one of the very closest of the external systems. So do go and find it, easy with binoculars, and when the moon's not there, easy also with the naked eye. Also close to Andromeda, there are two more constellations worth finding. One is Aries, the ram, often called the first constellation of the zodiac, which it once was, though it now isn't. The brightest star there is orange, called Hamel, but the interesting one is Mesartim, or Gamma Arietis, which is the third member of the trio, not very bright, but when you look at that through a telescope, you'll find it's made up of two stars, and these are perfect twins, not very far below binocular range, and almost any telescope will separate them. That's one of the most perfect pairs, I think, in the entire sky. And between Aries and Andromeda, there's another small constellation. This is Triangulum, the triangle, which really does look like the object is meant to represent, where the three main stars do make up a triangle. They are not very bright, but here there is another spiral galaxy, M33. You can find that quite easily with binoculars, although oddly enough, the surface brightness is low and is quite elusive telescopically. That picture, of course, is a false colour picture, but it does show the form of M33, a looser spiral than the Andromeda spiral, rather further away and considerably smaller. It's about 2.3 million light years away from us. It is worth finding. Now, also from the square of Pegasus, we can locate the most southerly of the first magnitude stars ever to be seen from Britain. And this is Fomalhaut in the southern fish. What you do, take a line from Scat through Markab, extend it downwards almost to the southern horizon, and there you will find Fomalhaut. From North Scotland, it barely rises. It's one of our closer neighbours, 22 light years away, 13 sun power, and very interesting. In 1983, the infrared astronomical satellite IRAS went round the Earth and mapped the sky in infrared. And around certain stars, it discovered cool material. And one of these was Fomalhaut. And it could be that Fomalhaut contains this kind of material around it. I am not saying that there is a planetary system around Fomalhaut. I am saying that there could be. And as planetary centers, it is quite a good candidate. Although whether that impression is accurate or not, only time will tell. Well, Fomalhaut's easy to find. The only danger is confusing it with Difta or Beta Cetae, which you can find by using the other two stars in the square, Alpheratz and Algolib, and they lead down to Difta. But Difta is a magnitude fainter than Fomalhaut and rather higher up, so I don't think there's much need for confusing the two. Cetus, the whale, which Difta is the leading star, is not very conspicuous, but it's not difficult to find. The most famous object there is the red variable Mara, which has a period of 331 days and can reach the second magnitude, but at the moment it's near minimum and is visible with the naked eye for only a few weeks every year, so at the moment I'm afraid you need binoculars or a telescope to find it. And also in the whale's head, there's another spiral galaxy, the massive Messier 77. And that's different, as you can see, from M31, with a big nucleus, our active center, and tightly wound spiral arms. Rather below binocular range, but a small telescope will show it. Well, there are plenty of other things to be seen. For example, let's come back to Cassiopeia. Use two stars of the W to find the sword handle in Perseus. And that's made up of two open clusters side by side. And not far away, we are coming now to the lovely Seven Sisters or Pleiades, the most famous of all star clusters. This is my own small-scale picture, and here's a much larger view of it, showing the nebulosity spread among the stars, showing that the Pleiades is a young cluster. And when you start to see the Seven Sisters in the evening skies we're doing now, I always know that winter, with its frost and fogs, is not too far away. So all in all, even though we haven't yet got around, there's plenty to see in the autumn sky. Don't forget, if you want the latest information, then ring up our Sky at Night information line, and the number is 0891 80030, or dial up CFAX, page 615. When I come back next month, we're going right out into deep space and talking about gravitational lenses. So until then, good night.